We're going to continue exploring patterns and tables of values. We're focusing on quadratics. After today's lesson, you will be able to identify quadratic functions from a table, as well as describing the rate of change for a quadratic from a table. The table below shows the height of an infield pop fly hit by Nolan Arenado. However, Dodgers third baseman Justin Turner loses the baseball in the glorious Colorado sun and it falls to the ground. Find the rate of change in the table. So what we have here is we have the time in seconds and we have the height in feet. So even though I'm calling this time, I can still think of this as X and I can still think of the height as Y. So you're going to start like we always do with the change in Y and the change in X. So please find that now. You can see here that my change in X all the way down my table. So the time is increasing by 1 in my table, the X value. And my Y value, which is the height of that pop fly, is increasing and then decreasing, but not by the same amount. So you see that we have different amounts here. We're asked to find the rate of change in the table. As you can see here, we have many rates of change. We have, recall that rate of change is always the change in Y over the change in X, which is change in Y over change in X. So I would have 14 over 1, 10 over 1, 6 over 1, 2 over 1, negative 2 over 1, and so on. We would have many different rates of change. So let's describe what we're seeing here with the change in Y values. We can see that the change in Y is not constant. This also tells us that the function is not linear because the change in Y over the change in X is also not constant because the change in X is always 1 in this situation. You might notice that there's some patterns here. See how I see 10 and negative 10, 6 and negative 6, 2 and negative 2. I see some opposites. So I'm seeing some opposites. And I see that there should be a turning point because I go from increasing to decreasing right here. And this should point to my turning point. You can also tell it's the turning point because it's the only Y value that's not buddied up. So see how there's 33 and 33, 27 and 27, 17 and 17, but there's no partner for the 35. That lets you know that this is a vertex. So we should note here that this can't be, even though there's a turning point, that this is not going to be absolute value because I don't have a constant positive change and then a constant negative change that are opposites. I have all these opposite values, but there's many rates of change in my two areas. So I know my graph is going to be increasing and then decreasing, but it is not going up at a constant rate like a V. So what we're going to do is we're going to find the change in our first set of. So these are our first set of changes right here, our change in Y's, and we're going to find the change in those. So from 14 to 10, I am decreasing by 4. 14 minus 4 gives me 10. I'm still decreasing from 10 to 6. I'm decreasing by 4. From 6 to 2, I'm decreasing by 4. 6 minus 4 is 2. That's how you're checking that. From 2 to negative 2. From 2 to 0 is 2, and then from 0 to negative 2 is 2 more. So I'm still decreasing by 4. And you're going to continue down your table. You can see here that from positive 14 all the way down to negative 18 is decreasing the whole way. And so you can, and these values stay decreasing by 4 for what we call the second difference. So this right here is going to be labeled second difference. You can abbreviate that like I did if you want. So our second difference is constant. The change of our changes is constant. So we're going to write that right here, that this is constant. And it is decreasing, our change of change, or a second set of changes, is decreasing by 4. Now it says, how long does it take for the ball to hit the ground? So how long is time? So we are looking at the X value. So when does it hit the ground? What does it mean to hit the ground in terms of the height of the ball? That means that our height is going to be 0 feet from the ground. We don't see 0 feet, but we see that 0 would come somewhere between 3 and negative 15. So shortly after 8 seconds is when the ball is going to hit the ground. So we can say between 8 and 9 seconds. You could also say just after 8 seconds. It's going to be closer to 8 than it is to the 9 because 0 is closer to 3 than it is to negative 15. Finally, what is the maximum height of the baseball? So recall when we were talking about this that we see right here that it is increasing then decreasing. So that ball is going up and then it's coming back down for a pop fly. And so the maximum point is at the vertex. And we circled our vertex right here. And so at 4 seconds, it is at 35 feet. So that would be our maximum height at 35 feet. We call this a quadratic function. You might recall that from our opening card sort activity. We're going to talk more about those key characteristics on the bottom of this page. How to identify a quadratic function from a table. So one of the things we look for is a constant second difference. And what that means is that the rate of change changes by a constant value. We know in a table that we are going to see a turning point. And remember that a turning point is called a vertex. And you also are going to see some numbers repeat with the y values. Also, your y values are going to be increasing, then decreasing, or decreasing and then increasing. In a table, that's going to look like positive values and then negative values. On a graph, it's going to look more like this as a U-shaped curve upside down. If it's decreasing first, you're going to have some decreasing changes and then some increasing changes, and that would look like this. Finally, rate of change, just to say how are we going to describe our rate of change because it's not constant. What you're going to talk about is how the rate of change is changing. So we would say that the rate of change is increasing or decreasing by the same amount. That's what the second difference being constant is described as. And that is talking about that our second difference is constant. That's how we describe it.